All right, our first application of integration is the area between curves. And the difference between the area and the integral, of course, is that the integral is a net signed area, whereas area is always positive. Think about the area of a circle or the area of a square that you learned about in geometry. You never learned that an area could be negative because it can't be. Kind of like how distance traveled is always positive, area is always positive. So in order to find the area between curves, we have to find a way to integrate, but make sure we're considering all of our areas positive, even if they're below the x-axis. There is a very simple way to do this, and that's what we're teaching you in this video. So what you're going to do to find area is to carefully shade the region whose boundaries are specified. And then you're going to write an integral expression to determine the area. And then you are going to integrate without a calculator where possible, but many of the ones in this lesson do involve a calculator. And we will integrate to 3 decimal place accuracy. So the first one we're going to do is f of x equals the natural log of x plus 1. The graph is given to you here, and the x-axis on the interval from 0 to 1.5. So the very first thing that we're going to do is to shade the region. And be clear that the region has to be bounded by the graphs or the information given, not necessarily by an axis. So this one did say it's being bounded by the x-axis. So we know that we've got the ln of x plus 1 here. We're only going to 1.5, and we are being bounded by the x-axis. So here is our region. We are shading it. Let's shade it with these vertical lines to give the impression that we are going to be taking the integral with respect to the x-axis. So the integral expression we'll set up is to find the integral from 0 to 1.5 of the natural log of x plus 1. And this is something that you'll want to plug into your calculator. So hit pause and plug it in and come back and check your answer. This is a great time to practice with your calculator. So please do this to make sure you're good with your calculator skills. The answer here is 0.790 or 0.791 because you're allowed to either round, which would be the 790, you're allowed to truncate, which would be the 790, or you can round to 791. Remember that you do need 3 decimal place accuracy for everything in AP Calculus. So this was a fairly straightforward problem because the integral was equal to the area because this region is entirely above the x-axis. So now let's get a little bit more tricky and let's introduce a new limit of integration that is a negative 0.05. So now if I integrate from negative 0.05 to 1.5, I've got this region here that is below the x-axis and this region here that is above the x-axis. So what I need to do is I need to split my integral into 2 parts because if you think about it, the x-axis, which is one of my boundaries, and the ln of x plus 1, which is one of my boundaries, they intersect at the origin. So when you are integrating with respect to the x-axis, you are going to follow the rule top curve minus bottom curve. And that's what we did for the first equation. We took ln of x plus 1 minus the bottom curve, which was y equals 0. So I didn't write it out here, but I really was subtracting 0. So for this section right here, what I'm going to do is I'm going to integrate from negative 1/2 to 0 of my top curve 0 minus my bottom curve ln of x plus 1. And then I'm going to add to that the integral that we already found representing this area, so 0.790 or 791. Let's just do 7907 for now. So what we just did by taking the integral of the top curve minus the bottom curve is effectively we have negated the integral. So if I rewrote this, let's try another color to let it stand out. 0 minus ln of x is really just negative ln of x, so I can pull out the negative sign and I can integrate the natural log of x plus 1 from negative 1/2 to 0. Well, what that negative sign does is it takes an integral, which is negative since the area or the region is below the x-axis, and it negates that negative integral to make it into a positive area. So now when you plug this piece into your calculator and add it to the 0.7907 that we had from the first problem, you will get the area, the total area bound by -1/2 and 1/2. So hit pause and make sure you can get the right area and check back in here in a moment. And the combined area you get should be equal to 0.944.